Modern agriculture has a belief problem. Not a lack of data problem. Not a technology problem, a belief problem. Somewhere along the last few decades, size stopped being a variable and became a virtue. Bigger machines were no longer tools chosen for specific conditions. They became symbols of progress, of efficiency, of seriousness. If your equipment was larger, heavier, more powerful, you were seen as advanced. If it wasn't, you were behind, outdated, sentimental. This belief didn't emerge by accident. It was engineered. As farms expanded, labor became scarcer, margins tighter, and time more valuable. Machines grew to cover more hectares per hour. More horsepower meant fewer passes. Fewer passes meant lower costs. At least on paper. And paper became the primary surface agriculture was optimized for. Spreadsheets loved bigger machines. Balance sheets loved them even more. So the industry followed. Manufacturers scaled up frames, axles, tires, and implements. Weight increased quietly, often framed as a side effect rather than a core variable. Marketing focused on output, on capacity, on dominance. What happened below the surface was rarely discussed. Because soil doesn't send invoices. It doesn't issue alerts. It doesn't break dramatically. It degrades slowly, invisibly, politely. For a long time, that politeness was mistaken for resilience. Farmers were told soils could handle it. That modern tires reduced pressure. That flotation solved everything. That compaction was shallow and temporary. That biology would fix it. And most importantly, they were told that if yields were stable, nothing was wrong. That assumption was fatal, because soil damage does not announce itself in the same season, or even the same year. It accumulates. It stacks quietly beneath the root zone, beyond the depth of tillage, beyond the reach of casual observation. What agriculture optimized for was speed and scale. What it neglected was load and pressure over time. And the heavier machines became, the more this imbalance grew. This video is not an argument against technology. It is an argument against blind escalation. Because bigger machines did not make soils worse by existing. They made soils worse by being treated as universally harmless. The problem is not horsepower. It's weight without restraint. The problem is not efficiency. It's efficiency measured only in hectares per hour. And the most dangerous part of this dogma is not that it is wrong. It's that it feels right. When you sit in the cab of a massive machine, floating above the field, isolated from vibration and resistance, it feels like control. Like mastery. Below that cab, the soil experiences something very different. And it remembers. The increase in machine weight was never announced as a decision. It happened the way most structural problems happen in modern systems. Incrementally, logically, and with everyone agreeing at every step. No one woke up one morning and said, let's compact soils for the next 30 years. They said, let's make this faster. Then, let's make this wider. Then, let's make this more powerful. Weight followed quietly behind. Bigger headers required stronger frames. Stronger frames required thicker steel. More horsepower required heavier drivetrains. More capacity required larger grain tanks. Larger tanks required reinforced axles. Each change made sense in isolation. And that's the trap. Modern agricultural machinery is a monument to local optimization. Every component is designed to solve a specific bottleneck. Very few are designed to respect the system they operate on. Soils became the silent partner in this escalation. Always assumed to adapt, always expected to absorb the consequences. The industry leaned heavily on one comforting idea: ground pressure. As long as pressure per square centimeter was low enough, weight supposedly didn't matter. Wide tires, duals, triples, tracks, flotation became the magic word. And to be fair, surface pressure was reduced. But soil is not a flat, rigid platform. It's a layered, living structure. Pressure dissipates downward. Weight does not disappear. It transfers. At shallow depths, flotation helps. Below that, mass wins. Once axle loads cross certain thresholds, compaction moves past the topsoil and settles into the subsoil. This is where the real damage begins. And where almost no one looks. Subsoil compaction doesn't show up as ruts. It doesn't scream for attention. It doesn't stop the machine. It just slowly restricts root growth, water infiltration, gas exchange, and biological activity. Quietly shaving potential off every crop cycle. The heavier machines became, the more this damage became inevitable. Especially under modern timelines. Fields are worked when calendars demand it, not when soils are ready. Short planting windows, narrow harvest margins, logistic pressure, weather volatility. If the machine can go, it goes. Moist soils plus high axle loads equal deep compaction. This has been understood scientifically for decades. Yet operational reality kept ignoring it. Because stopping costs money, waiting costs money, running costs money too, but that bill arrives later, disguised as normal variability. Another accelerant was consolidation. As farms grew larger, machines had to replace people. One operator, one pass, one massive tool. Redundancy disappeared, flexibility vanished. Everything depended on a few critical machines performing flawlessly and constantly. When those machines are heavy, the soil pays the price every time they move. Ironically, the same systems designed to increase efficiency reduced adaptability. Smaller machines could wait, they could split workloads, they could avoid marginal conditions. Bigger machines demand commitment. Once they roll everywhere. Manufacturers did not push back. They followed demand, and demand was shaped by economics, policy, and cultural signaling. Big machines became status markers. Proof of seriousness, evidence of success. You don't just farm, you operate at scale. No one posts pictures of healthy pore structure. They post machines, and so weight kept increasing, hidden behind better cabs, smarter software, and cleaner marketing. By the time anyone questioned it, the baseline had shifted. What would have seemed absurdly heavy 20 years ago was now normal. That's how systems drift, not by breaking rules, by redefining them. Modern agriculture loves what it can see. Emergence, canopy color, uniformity, yield maps with clean gradients. Everything below that gets ignored unless it fails catastrophically. 30 centimeters became a psychological boundary. If the topsoil looked fine, the system was declared healthy. This was convenient, also deeply wrong. Below that depth lies the subsoil. Not dead, not inert, not irrelevant, it is the structural backbone of the field. Roots don't stop at 30 centimeters because they feel polite. They stop because something blocks them. When heavy machinery passes over soil, the force does not vanish at the surface. It travels downward in a cone-like distribution. The heavier the axle load, the deeper that force penetrates. At a certain threshold, soil particles rearrange permanently. Pores collapse. Macroporosity disappears. Density increases beyond natural recovery. This is not compaction you fix with a pass. This is structural damage. The irony is brutal. The deeper the compaction, the less visible it becomes. Plants adapt at first. Roots thicken, branch laterally, search for oxygen. Crops still emerge, yields hold, everyone relaxes, but the system is now operating with a handicap. Water infiltration slows. Instead of moving vertically, water spreads laterally. Saturation increases. Anaerobic zones expand. Microbial balance shifts. In dry years, roots cannot chase moisture downward. In wet years, excess water cannot escape. The field becomes fragile, oscillating between stress extremes. This is why compacted soils perform fine until they don't. Weather volatility exposes them. The modern climate doesn't forgive shallow resilience. It demands depth. Subsoil compaction also traps nutrients in unreachable zones. Fertilizers accumulate above dense layers. Roots never reach what was paid for. Input efficiency drops silently. The response is predictable. More fertilizer, more correction, more cost. The system masks its own injury by injecting support. From the surface, it looks like management. From below, it's compensation. One of the most damaging myths is that biology will always fix this. Biology is powerful, but not magical. Roots and organisms need pathways. They need oxygen. They need time. When density exceeds certain limits, biological recovery slows to geological timescales. Earthworms cannot drill through concrete. Roots cannot breathe through steel. Deep compaction zones often persist for decades, especially in climates without freeze-thaw cycles strong enough to fracture dense layers. Subsoiling is presented as the solution. A reset button. Sometimes it helps, often it doesn't. Mechanical loosening without structural support collapses back under load, especially when the same heavy machines return the next season. It's a treadmill. Break the soil, fix the soil, break it again. And because yield loss is gradual, this cycle is normalized. No alarms go off, no dashboards flash red. The damage is amortized across seasons. The most dangerous damage is the kind you learn to live with. Below 30 centimeters, the soil remembers every pass, every axle load, every wet day decision. It remembers what the spreadsheets forget. The most expensive problems in agriculture rarely announce themselves. They don't arrive as failures. They arrive as normal. A slight drop in response to fertilizer. A field that dries slower than it used to. Roots that look fine, just shorter. Yields that hold steady, but never quite push higher anymore. This is how invisible compaction makes its money. Farmers are trained to look for dramatic signals. Ruts, ponding, stunted crops. But deep compaction does not behave theatrically. It behaves economically. It shaves potential. A few percent here, a few percent there, year after year. And because modern agriculture is already noisy with variables, those losses get absorbed into the background. Weather, genetics, market timing, anything but soil structure. Yield monitors don't measure missed opportunity. They measure what survived. Compacted subsoil limits root volume. Less volume means less access to water and nutrients. The crop becomes more dependent on perfect timing and external inputs. When conditions are ideal, the field performs. When they are not, it collapses faster than expected. That fragility is the true cost. And it scales. On large operations, a 1 or 2% efficiency loss is not a rounding error. It's millions quietly redirected into inputs, fuel, and mitigation. This is why compacted fields often look high maintenance. They need more nitrogen to hit the same protein, more passes to manage moisture, more correction to stay responsive. The system compensates instead of correcting. Heavy machinery plays a central role in this loop. Each pass adds load memory to the soil. Even with controlled traffic, the axle loads remain the same. You are concentrating damage, not eliminating it. Controlled traffic farming helps. It does not erase physics. Once a traffic lane is compacted deeply, it stays that way. Roots avoid it, water bypasses it, biology works around it. The crop becomes segmented by infrastructure instead of soil logic. Another hidden cost is time sensitivity. Compacted soils narrow operational windows. You can't enter fields as early. You can't plant as flexibly. You can't recover from weather delays as easily. Ironically, the machines designed to save time end up making time more expensive. When the system is tight, any delay cascades. Decisions become reactive, soil protection becomes negotiable, and heavy machines are unforgiving under pressure. The industry response has been predictable. Better tires, better tracks, better marketing. What hasn't changed is axle load, the number that actually matters at depth. It's uncomfortable to admit that progress created a problem it cannot easily solve without stepping back. Because stepping back feels like regression, and modern agriculture hates that feeling. So instead, the damage is priced in. Farmers don't calculate compaction loss explicitly. They feel it as stress, as volatility, as fields that never quite behave. The soil is still producing, just not freely. Invisible damage is the hardest to fight because it doesn't look like damage. It looks like management getting harder. And harder systems always blame the operator before they blame the design. Modern agriculture measures everything: yield per hectare, fuel per hour, seed spacing down to millimeters, moisture content in real time. And yet, one of the most consequential variables in the system is almost never tracked seriously: subsoil compaction. Not because it's impossible, because it's inconvenient. Measuring deep soil structure is slow, messy, and deeply unsexy. It doesn't fit dashboards. It doesn't update in real time. It doesn't flatter decision-making. Pentrometers exist. Soil pits exist. Bulk density tests exist. Decades of research exist. What doesn't exist is incentive. There is no immediate payoff for diagnosing a problem that has no quick fix. There is no dealer program that benefits from telling you your main assets are slowly degrading the foundation of your operation. And there is no cultural appetite for data that implies limits. Precision agriculture optimized for what could be digitized easily. Compaction at depth resists that treatment. It demands interpretation, context, humility. It also demands accountability across seasons. A yield map can tell you what happened this year. A compaction profile asks what you've been doing for the last 10. That's uncomfortable. So instead, agriculture measures proxies. Emergence uniformity, NDVI, in-season stress signals, all useful, none diagnostic. By the time those indicators light up, the damage is already structural. Another reason this goes unmeasured is fragmentation of responsibility. The person buying the machine is not the person designing it. The person operating it is not the person modeling soil physics. The person selling inputs is not rewarded for reducing dependency. Everyone touches a piece of the system. No one owns the outcome below ground. Manufacturers talk about pressure, not load. Agronomists talk about chemistry, not mechanics. Economists talk about scale, not soil strength. The gaps line up perfectly. Research institutions do publish warnings. Axle load thresholds are known. The relationship between moisture, load, and depth of compaction is well documented. But research moves slower than markets. And markets move toward what sells. Big machines sell, limits don't. There's also a psychological factor. Measuring something implies you might have to change behavior. Once you know, you can't unknow. It's easier to assume soils are resilient than to confirm they're not. So the system defaults to optimism. Fields are declared fine because they are still producing. Compaction becomes a hypothetical future issue, not a present constraint. Until a drought hits, or a wet harvest locks fields out, or roots stall inexplicably, then everyone acts surprised. But surprise requires ignorance. This is neglect. The absence of measurement is not neutral. It actively preserves the status quo. It allows weight escalation to continue without friction. What isn't measured isn't managed. What isn't managed gets exploited. And soils have been remarkably patient about it. Once deep compaction becomes part of the system, it rarely stays alone. It invites company. The first guest is inefficiency. Roots explore less volume. Water moves slower. Nutrients stack where plants can't reach them. The crop becomes less autonomous. Autonomy is expensive to lose. When soils stop doing work for free, someone else has to step in. Usually with a tank, a spreader, or a prescription map. More nitrogen to compensate for shallow roots. More fungicide because stressed plants get sick easier. More passes to manage moisture extremes. More correction to maintain normal performance. This is not a failure of inputs. It's a demand created by structure. Heavier machines push the system into a dependency loop. Each increase in axle load tightens tolerance. Timing matters more. Weather margins shrink. The crop needs help sooner and more often. From the outside, this looks like intensification. From the inside, it's fragility management. The brutal part is that this loop feels productive. Inputs work. Yields respond. The system gives feedback that looks like success. But the cost curve steepens. What used to be optional becomes mandatory. What used to be insurance becomes baseline. And once inputs become baseline, removing them feels like risk. So no one does. This is how soils get locked into high input states without anyone deciding it consciously. Heavy machinery accelerates this lock-in by compressing the soil's ability to buffer mistakes. In a resilient soil, a late pass or a wet entry hurts but recovers. In a compacted soil, the same decision leaves scars. Those scars accumulate. Eventually, the farm is no longer optimizing yield. It's optimizing damage control. Every season becomes a negotiation with constraints that didn't exist before. And because those constraints are underground, the response stays above ground. More technology, more precision, more complexity, none of it addresses the cause. There is also an energy penalty. Compacted soils require more force to penetrate. Tillage gets harder. Fuel use creeps up. Wear increases. Machines get even heavier to compensate. The feedback loop tightens. Weight causes compaction. Compaction demands power. Power demands weight. At no point does the system pause to ask if this direction still makes sense. Because stepping out of the loop feels like falling behind. And modern agriculture is terrified of falling behind. Input suppliers thrive in this environment. Not out of malice, but alignment. Systems that require constant adjustment generate steady demand. Healthy soils are annoyingly self-sufficient. Degraded soils are reliable customers. This isn't a conspiracy. It's momentum. Once soils lose structure, everything costs more. Money, time, attention, stress. The farmer becomes a systems integrator, juggling chemistry, logistics, and weather just to hold ground. And the machine that started the chain reaction keeps getting bigger. Because the system now depends on it. Not every agricultural system doubled down on weight. Some hit the wall earlier. Some paid the price faster. Some listened when soils stopped cooperating. And quietly, without marketing campaigns or press releases, they started backing off. Northern Europe was one of the first regions where the problem became impossible to ignore. High rainfall, fine textured soils, and short operational windows are a brutal combination for heavy machinery. When axle loads increased, damage appeared fast and stayed visible. Fields lost trafficability. Rooting depth collapsed. Yields became erratic instead of trending upward. The response was not nostalgia. It was constraint-based innovation. Several countries began setting explicit axle load limits. Not recommendations, limits. Machines could be powerful, but weight per axle became non-negotiable. This forced design changes. More distributed loads, more axles, smaller grain tanks, Modular systems instead of single massive units. Efficiency was redefined. Instead of hectares per hour, systems optimized for hectares per season without degradation. That shift matters. In controlled traffic systems across parts of Australia, weight management became central. Not just where machines drive, but how much they carry while doing it. Operators began unloading earlier, running partial tanks, accepting more trips in exchange for soil protection. On paper, this looked inefficient. In practice, it stabilized systems. Fields stayed workable longer, yield variability decreased, input response improved, the system paid back slowly, then consistently. In Japan, where soils are sensitive and land is scarce, machines never reached the absurd sizes seen elsewhere. Precision came from control, not mass. Lightweight design wasn't ideological, it was necessary. In parts of South America, the story is mixed. Rapid-scale expansion pushed machine size aggressively, but regions with long-term no-till experience began noticing yield ceilings that inputs could not break. Research followed practice. Subsoil compaction under no-till with heavy machinery became a serious topic. Some operations started experimenting with lighter fleets, staggered loads, and seasonal restrictions. The key insight across these cases is not that big machines are banned. It's that they are constrained. Power is allowed, weight is questioned. That distinction is critical. Once weight becomes a design variable instead of an afterthought, behavior changes. Decisions slow down. Operators wait for conditions instead of forcing them. The culture shifts from domination to negotiation. And that is deeply uncomfortable for systems built on speed. These regions didn't collapse economically. They adapted. Labor requirements changed, logistics adjusted, profitability didn't disappear. What disappeared was the assumption that bigger is always better. That assumption is expensive. What's fascinating is how quietly this retreat is happening. It doesn't fit the global narrative of linear progress. It doesn't sell well, so it's rarely highlighted. Instead, the global industry keeps exporting its heaviest solutions to places where soils haven't failed yet, where the bill hasn't arrived. But soil physics doesn't care about borders. The delay is not forgiveness. It's interest accruing. Countries that are stepping back are not anti-modern. They are post-naive. They already tried scale without limits. They already paid, and they learned that soil does not negotiate forever. Technology was never the enemy. That's the lazy conclusion, the comforting one, the one that lets everyone keep their identity intact. The real problem is how technology was aimed. Modern agriculture invested heavily in control above ground and almost none below it. Sensors multiplied, screens grew, algorithms optimized passes, rates, and timing. All impressive, and all largely blind to soil structure. Technology became an amplifier of existing assumptions. If the assumption was that soils could take the load, technology helped deliver that load faster, more precisely, and more often. That's not innovation, that's acceleration. Smart systems were wrapped around heavy machines without questioning whether the machine itself was appropriate for the task. Auto steer doesn't reduce axle load. Variable rate doesn't restore pore space. Telematics don't loosen subsoil. They make execution cleaner, not consequences lighter. Intelligent technology starts with constraints, not capabilities. It asks what the system can tolerate before asking what it can achieve. In soil-sensitive systems, intelligence looks boring from the outside. Lower axle loads, more axles, more trips, smaller tanks, seasonal rules. None of this sells well on a billboard. But it works. There is a growing divide between high-tech farming and high-resolution farming. The first focuses on tools. The second focuses on limits. High-resolution systems pay attention to thresholds. Soil moisture thresholds, load thresholds, recovery thresholds. They accept that some days are no-go days. They design fleets around that reality. This is where technology actually shines when applied correctly. Real-time soil moisture mapping, load sensors tied to decision rules, systems that say no. That's the part the industry avoids. A machine that refuses to operate under damaging conditions is not popular. A system that slows operations is not glamorous. But it is intelligent. The most advanced systems emerging are not the biggest. They are the most aware. They integrate mechanics, biology, and logistics into a single decision loop. Instead of asking, "Can we run?" they ask, "Should we?" That question alone changes everything. Lightweight robotics are often cited as the future. Maybe, maybe not. The real future is not small machines everywhere. It's appropriate machines, deployed intentionally. Sometimes that's a robot. Sometimes it's a mid-sized tractor instead of a monster. Sometimes it's 2 passes instead of 1. Efficiency redefined. Smart agriculture is not about domination. It's about alignment. When technology aligns with soil limits, yields stabilize. Inputs work better. Stress decreases. Decision-making improves. When it doesn't, technology becomes a mask, a way to ignore foundational damage while optimizing around it. The tragedy is that the tools to do this right already exist. What's missing is cultural permission to prioritize restraint. And restraint still feels like weakness in a system addicted to scale. Modern agriculture doesn't like limits. It was built on the promise that every constraint could be engineered away. Weather, labor, pests, distance. If something resisted, the answer was more power, more chemistry, more scale. For a long time, that worked. Until it didn't. Soils were treated as infinitely resilient platforms instead of finite structures with memory. Heavy machines didn't break them overnight. They taught them to fail slowly. That's why this problem is still debated. Slow damage feels theoretical until it becomes unavoidable. The uncomfortable truth is that many farms are not dealing with isolated issues. They are dealing with accumulated consequences. Consequences of weight applied too often, under too much pressure, for too long. Bigger machines didn't destroy soils out of malice. They did it out of alignment. The system optimized for speed, not tolerance. For output, not recovery. And now agriculture is managing around that mismatch. The hardest part is that the solution does not look like progress as we've been trained to recognize it. It looks like restraint, like rules, like saying no to some efficiencies. It looks like accepting that more trips can be better than one heavy pass. That waiting can be cheaper than forcing. That designing for soil limits is not weakness. It looks boring, but boring systems last. The future of agriculture is not small machines everywhere, nor is it ever-growing monsters rolling across exhausted fields. It is systems that respect thresholds. Power will continue to increase. Technology will continue to evolve. None of that needs to stop. What needs to stop is pretending that soil physics will adapt indefinitely. Soils are not against progress. They just demand honesty. They remember what we do to them. They reflect it back, slowly and without negotiation. Bigger machines made agriculture faster. They also made its mistakes heavier. The next era won't be defined by how much weight we can move. It will be defined by how much we choose not to. And that choice is no longer theoretical. It's already overdue.